So what are the options of the wine industry? Well, in one way is to come up with better bentonites, and a lot of work is being done in that area. Another option is to find alternative products or technologies to stabilize wine that do not require the use of bentonite. So in the bentonite efficiency side, people are playing with different types of bentonites, playing with the timing of application. So when you add it, ends up changing the amount required to stabilize a wine. Also playing with addition and separation methods. So batch addition versus inline dosing and removal. And also playing with coming up with better predictive tests to predict the right amount of bentonite, so to not overfine the wine with this compound. The other options are to find alternatives. So people like myself have been looking into enzymes, into different fining agents, into different processes. So by using the knowledge generated by coming up with a method of mechanism of formation of haze, we can tailor or try to target some solution to the process. And I'm going to show you some of those now, some of the alternatives to bentonite. So people have been looking on alternative fining agents. So stuff that works a little bit like bentonite. You add it to the wine, binds to the protein, and then you remove it from the wine alongside with the proteins. Things like polysaccharides like Carrageenan, Zirconia, magnetic nanoparticles, zeolites, kiting, tannin addition, or not really a fining agent, but a stabilizer like polysaccharides produced by yeast have also been looked at. Proteolytic enzymes, the ideal solution, the holy grail, if you want, of this field, and also ways to, by processing, for example, by pasteurizing, microwaving, applying high pressure treatments or pulse electric field, denature the protein, destabilize the protein in the cellar and not in the bottle, to so that the aggregation can happen in the tank and be removed in that while the wine is not bottled yet. So I'm going to show a few of those, some of the most interesting ones that have been published in recent time. One, I start with natural zeolites. See, these are sodium and calcium aluminum silicates. They are a little bit like bentonite, so they're negatively charged at wine pH. Advantage here is that they don't have this shrink and swell behavior. When you hydrate bentonite in water, it is swelled, and this is where the wine is trapped later when you end up with a lees with the bentonite wine and protein trapped together. So in this experiment done by Australian Wine Research Institute researchers published in 2019, they treated 3 wines with high protein content, high instability level, with industry standards, so 2 types of bentonite or natural zeolites, and the wine could be stabilized. However, you can see here from the numbers, while the wine can be fully stabilized, there's a removal of potassium. Another advantage is that you don't have lees or very little amount of lees, so very little amount of wine trapped. They need to be treated later on. The negative side is that it requires high dosages. The OEV needs to approve that if this will become a commercial solution, and the cost is not known yet, but at the moment, as every solution that you develop, the cost tends to be quite high at the beginning of the process. So promising, but not there yet. Another one is mesoporous material, zirconia. This is work that has been done about a decade ago now, but has shown the ability to, when you add the zirconia, which looks like this picture down here, I hope you see my arrow when I indicate, is a material that you add it to the wine, is a mesoporous, so it has small porosity, so the protein will enter into these pores and then they will be trapped. So basically the protein will stick to the zirconia, and then you will remove the zirconia, which is insoluble, without having lees, and that would be quite advantageous. Here you can see that from adding zirconia at day 3 of a fermentation, you can see how the protein content, this is what in the y-axis is decreased quite dramatically in a couple of days as opposed to the control. So the pros here is that if used during fermentation, it increases fermentation rate. It can be reused by washing with sodium hydroxide. It can lead to stable wine produced without any lees and without sensory or compositional changes. The negative side, a bit like the zeolites before, is that you need a lot of zirconia to reach this target. It removes some metals from the wine. This is a disadvantage, but can also be an advantage in some case. And it only works with stirring. So if you use dual fermentation, good. But if you use it in the wine, then you need to mix the wine when this is happening. And so this is a unpractical solution. Another fining agent, this type is a cell wall polysaccharide that you start from red seaweeds, widely used in many industries, is Carrageenan. This is also negatively charged at low pH.